So, as promised, I'm preparing a demo on a few things. First, it's going to be about a little orientation into our perspective space. We're going to be talking about creating a perfect square on the ground plane using 2 point perspective. And ultimately, we'll be going into some principles like finding a perfect cube, finding the perfect cube in 2 point perspective, and finding a perfect ellipse on one of the sides of that cube, and then about using the minor axes to extrude and to emboss details for a cube so that we could create things such as tires and other really cool effects that you might want to do. Um, and then, of course, we will be using those same principles to build up a bounding box and to use blueprints to create a technical drawing of a vehicle in our 3D space. So, what I have here is my working file, and I've demonstrated this before. It has all of the just rudimentary things that we would use in technical drawing, perspective drawing. Um, I want to note a few things here. I'll be turning off some of this stuff. This is primarily for demonstration, and I'll be referring to them a little bit. But I just want to go over some fundamentals. So, of course, we have our station point here, which is where our feet would be placed if we were looking at this. And we have our picture plane here, which represents a window that is perpendicular to your degree of I. So if I'm looking flat out across the horizon, this would be perpendicular or 90 degrees to the ground plane. Um, so we have a few things to note that my head would be kind of like right here in the middle, and where we have all of these converging, this X and this vertical and horizontal line, that would be my center of vision, and that would represent where my eye line is. So if I were standing here, my feet would be at the station line, my head would be somewhere in here, this would be my eye line. And we can rotate these things 90 degrees. So we can take this and imagine that we're standing back from this window, and then we compress everything down 90 degrees to the ground plane. Now we can picture our station point, not only where our feet are, but where our head is, as if we're looking from a drone shot straight down. Our head would be right here, and we would be viewing into that picture plane. And now this horizontal across the picture plane is as if the picture plane were upright, and we're just seeing it in profile, and so it just basically becomes a line, and then everything would be projected through there. Okay. Um, and we can rotate this station point 90 degrees around the center of our image to create very accurate measuring points that we'll talk about at some point. It's how we can find converging lines like vanishing points in perspective, such as our 3rd point perspective. So a zenith or nadir vanishing points if we are looking in 3 point perspective. Okay, so you can see that from our station point, we have some radiating lines. We have one straight at the middle, which we call our station line, which runs vertical through our picture plane and represents our center of vision here. If our horizon line, if our vanishing points converge to the very center of our picture plane, that means we're in 1 point perspective, which means that our z depth, our z axis, is everything that runs parallel to our z axis will converge at the center, where everything in our x and y axes will still remain parallel to the picture plane. Once we move our vanishing point west or east of the center of vision, we are now in 2 point perspective, meaning that we have both x and z axes in convergence. So anything that runs parallel to the x and z axes now has convergence, and our y-axis still remains parallel to our picture plane. And this is a pretty standard way to draw. And in this case, we'll be using that 2-point perspective. Okay. Now, once our center of vision moves north or south of the horizon line, so our eye line and our horizon line diverge. In this case, you can see in this picture plane, we have our center of vision eye line north of the horizon line, meaning that we're technically in 3-point perspective. Now I want to qualify this as you see this little caret here running from the west of frame, and it is on our horizon line, and it is at the station line if turned 90 degrees. So if you see it has this degree, which is 8 degrees north and 8 degrees south of the horizon line, and if we can keep it within that 8 degrees, we can still maintain 2-point perspective, and it'll still be believable. Once we sort of move beyond that, we need to start using our zenith or nadir vanishing points to create that 3-point perspective believably. So here at 8 degrees, we're doing fine. And so you can see my eye line at my center of my picture plane is 8 degrees north of the horizon line, meaning that I'm looking up 8 degrees. And I think that that's a really attractive way for doing vehicles, because it kind of gives us that Michael Bay feel, or we're a little bit low looking up to the vehicle. It makes the vehicles look a little bit more heroic, and really, really cool. And so we're going to use that when we work on our vehicle today. Okay? So, of course, our picture plane is X'd out, so we can find the center. We have even degrees and that kind of stuff. All right, so let me go ahead and click off my 8-degree cone, since you don't need that anymore. Where is it? Okay. Oofta. Where did I put it? Anyway, I'll find it. Here we go. 8 degrees north and south. Okay. And then we have our cone of vision here, which represents 30 degrees east and west of the center of vision, which is a total of 60 degrees, which is our pretty average for doing perspective drawing. And it allows us to have this circle here, where if we maintain our elements within our illustration within this cone, it won't distort as we start creating our perspective. Okay? And so I do have some corners here that are outside this cone of vision, and that's fine because I don't plan on putting any elements of my actual drawing in those corners. I do have one little corner here, but I doubt my vehicle will even touch that as well. So I feel pretty confident that the majority of my visual elements will maintain within this cone of vision right here. Even though we are north of the horizon line, we can still get some really, really nice composition in here. Okay, so I can go ahead and click that off, and these two lines, east and west of the center of vision, represent that cone of vision as if we were looking down at it from a drone from the top. So my eyes are here. This is 30 degrees. This is 30 degrees, and this is center of vision. Okay. Okay, so I'm going to go ahead and knock out the little converging center of vision in the middle of my picture plane. We're not going to need it. And then my cone of vision, we don't really need either. We know that we're pretty safely within that. Okay, so that leaves us with a few things here. And as you can see by the annotation, we have HL over here. It's notating that this is our horizon line. I've gone ahead and marked in vanishing point right and left, and you can see that they are not equidistant. Okay. And I did that on purpose because I want to have a little bit of a beauty shot. I don't want things exactly 45. I want the profile of the vehicle to be a little bit more visible, so we can kind of see those really cool details and stuff. And so what I've done is I've rotated my my center of vision point to the east this way over here, which allows it to then turn my vision, and I can see that vehicle's orientation slightly turned as well. And because of that, I need to make sure that my vanishing point left and vanishing point right still remain 90 degrees relative to each other and the station point. So you can see here that at the station point, there's these two lines that converge off to those vanishing points, and that they are 90 degrees to each other at the station point. So they meet there and they're 90 degrees, which allows me to have a 45 degrees somewhere off here. I do use those 45 degrees, and we'll probably do it today when we do the first demo, which is finding a perfect square flush to the ground plane in perspective. All right. So that's very, very important to make sure that this is 90 degrees always. Now I can change the orientation of any object within space and rotate it around. I just have to make sure that I continue to rotate these two vanishing points in a relationship to the station point and maintain that 90 degrees relationship, so that I have honest converging points relative to this ground plane and to each other. And I use what I call my 90 degree or right angle tool, which is this tool right here, to do that. So I can go ahead and I can take this corner here, this is just a vector path tool that I've created that's 90 degrees and a 45 degrees. So I can set this corner here right on this corner here, and I can rotate it from that corner and find new vanishing points that are relative to each other, as well as a 45 degree angle, this one here in the middle, that intersects that that horizon line and giving us that 45 degrees, which is, it's a very useful tool. It makes it quick and dirty, and so I use that quite a lot. Okay. In addition to that, I do have a color chart here, so I sort of try to keep myself organized with colors. Black is obviously our finish line. L is going to be things related to left of center. Red is going to be pretty much things right of center, meaning things relative to the vanishing point right. Orange I usually use for things like measuring lines. Yellow I don't use very often. Green I will sometimes use for things like bounding boxes or matrices that I need to kind of like, that aren't too aggressive, that I can kind of like gray down. Okay, so another point to make as we get into this, and I will demo it, is these 2 points here. These are called measuring points. So I have measuring point right and measuring point left. And what that represents is as from the vanishing point left, for instance, I have a length that leads to our station point. So this length of line right here into convergence becomes very, very important. And if I rotate this line from my vanishing point left up to the horizon line, so I just swing it like I hinge it here, so that this distance and this distance are the same, we get what's called a measuring point. So this is measuring point left because it is relative to my vanishing point left, and it will be right of center. Okay, and likewise we have measuring point right, as if I had rotated this length of line. So again, it's from the vanishing point right to the station point, and it's hinged at the vanishing point and swinging it up to the horizon line. So swinging it up to the horizon line until we get this distance here, and creates measuring point right. So this measuring point is relative to vanishing point right. So these things swing. These are going to be very useful tools, very useful points when we start creating our perfect cube in space, as well as when we start creating using blueprints to create a technical drawing of a vehicle. We need to be able to measure the distance of things and start basically modeling out that vehicle, and we need these accurate measurements. It is a pretty tedious thing, but the result is really, really very believable, and is a very powerful thing. Okay, so we'll be utilizing all these tools going forward, and make sure that we're able to create some really, really awesome illustrations as we go forward. Okay.